Oh, pre-algebra students, Mr. Lawrence here. We're going to do some application problems with the Pythagorean theorem. And at the end of the day, you'll be able to say, I can use the Pythagorean theorem to solve real-world problems. Now, you can ask my algebra kids, story problems are actually easy. They're scared of them just like you are because of the reading involved. But if you work at it, you can get it. And these aren't bad. And I've got to tell you, yours are going to be easier than theirs because you can draw a picture. And the picture will make it simple. All right, so let's get down to the first example. Your Uncle Sam has just erected a new flagpole. To help keep it stable until the cement dries, he's attached a guy wire to the top of the pole and to the ground. The wire is 40 feet long, and it is attached to the ground 30 feet away from the base of the pole. How tall is the flagpole? Well, I know you're thinking, Logan's going, I have no idea, this is magical. No, Logan, it's not. It's mythical. I don't think that's a word, but that's okay. First thing I'm going to do, Logan, is, well, I can do a better job than that. I'm going to draw my flagpole. And remember, be kind, Mr. Lawrence. Teaches math, not art. Okay, and I'll even put my little flag in there. All right. Don't have to put such detail, but there we go. Okay, now I need a wire. And my wire is going from the top of the flagpole to the ground, right? And I know that that distance, I was told it was 40 feet. That's the wire. 40 feet, right? Okay. And I know that the distance from the pole to where the wire hits the ground is 30 feet. Close that up. And look at that. What did I make here? Well, I made a right triangle. Now, because I'm having a little trouble with the airliner, I don't really have a beautiful right triangle, but I can, do that if you like. Put that in, make it look a little bit better. But you know it's supposed to be a right triangle. Okay, so the trick is I'm trying to find how tall the flagpole is, x. Well, since I have a right triangle, I'm going to use the Pythagorean theorem. Going to find my right angle, and I'm going to draw an arrow to the side opposite to identify C. In this case, C is 40, so I'm going to square 40. I'll make A the x length, and B will be the 30. I'm going to square everything. 900, 1600. By the way, if you put these in the wrong place, you don't get 40 in the right spot. The length of x will actually be longer than the hypotenuse, which of course can now be possible. All right, I want that x squared to be alone, so I'm going to subtract 900 from each side. Okay. We're going to get x squared equal to 700. To undo a square, I take the square root. I don't believe that's a perfect square, so I'm going to use my calculator. And the square root of 700 is going to be approximately 26.5 feet, and that's rounded to the nearest 10. See how simple that was? All you had to do is draw the picture. I actually think it's kind of fun because it's like I made something out of nothing. I looked at those words, turned it into a picture, and then applied a math to it. All right, one more example here. If you hear any strange creatures in the background, my son is awake and he's having some fun. Anyway, you're trying to swim across a river that is 25 feet wide to join some friends on a dock. Well, I'm going to draw my river. Here's my river. And I need a dock. So here's the dock, and here's my friends. I think they're fishing, right? Okay, that's unnecessary. Okay, now you're right here. You're getting ready to swim. Okay, and you're going to swim right across the river. You're going to go. The only problem is there's a current on the river, and it's going to drag you down here. So what ends up happening is you end up, instead of going right straight across the dock, which you would like to do, you end up down here. And look at this, I've got a right triangle developing, don't I? You wanted to go here, which was what, 25 feet? But you end up going here, and you know this distance. And there's the right triangle. And so I'm going to label the sides of my right triangle. Let me see here. The distance across is 25 feet. I'm going to put my right angle in, and you end up 200 feet down. Now, I know this doesn't look like 200 compared to 25, but that's okay. Okay, so I'm going to find my hypotenuse because I see my right triangle. I know that I'm going to use a squared plus b squared equals c squared. And I'm going to draw the arrow right here. Okay, and so c in this case is the unknown side. So I can call that x. I could leave it as c if I wanted to, but you guys are usually pretty good with x. The 25 and 200 don't matter which one's which. You can do 25 as a, 200 as b, or vice versa. It won't matter. So I'm going to square both sides, and this is going to be 625. And this is going to be quite a large number. 1, 2, 3, 4, 40,000 x squared. And so when I add those together, I'm going to get 40,625 equals x squared. And then I'm going to take the square root. I don't know if that's a perfect square or not. I suspect that it's not. It could be. Could fool me. But let me go ahead and use my calculator, take the square root of 40,625, and I will get approximately 201.6 feet. So the actual distance you swam, because the current drug you downstream, was 201.6 feet. In other words, if you held a tape measure while you swam from this point here to this point, that distance would measure 201 and 6/10 feet, okay, as opposed to just swimming right across 25 feet. All right, that's your lesson for tonight. Mr. Lawrence signing off. Good night, everybody.